Today I'm going to be covering a concept that has two different names in two different countries. So in the UK, this is known as standard form, and in South Africa, this is known as scientific notation. Both standard form and scientific notation mean the exact same thing. So what is scientific notation? Scientific notation is taking really big numbers and writing them as a small number, or taking really small numbers and just making them more accessible to us. When we talk about scientific notation or standard form, I'm going to interchange the two terms, but when I'm talking about scientific notation, I mean standard form and vice versa. When I'm talking about standard form, we have standard form being in the form of a times 10 to the power of n. If I'm talking about the a has to be a value between 1 and 9. So it can be 1, it can be 9, but it has to be a value between 1 and 9. Our base is 10, so we always times 10. And then the exponent, the n value, has to be an element of the integer system. So the n value can be a negative or a positive number, but this is how we write out our standard form. Our standard form, a times 10 to the power of n. I'm going to do a few examples of writing big numbers in scientific notation, small numbers in scientific notation, and then we're going to do a few going from scientific notation to our ordinary numbers. If we look at our first value of 4,000. 4,000 is a big number. How do I know that 4,000 is a big number? Well, the zeros are after the number. So when we're talking about big numbers and small numbers, an easy way to identify whether it's a big number or a small number is big numbers, the zeros are at the back of the number. Small numbers, the zeros are in front of the number. All right, so I have 4,000. 4,000 would be a big number, which means that I would be able to put my decimal place right at the back of the number. For scientific notation, I need one significant value in front of the decimal point, and then it doesn't matter how many decimal places I have after, so long as I only have one significant value in front of the decimal place. Now, that significant value is a number between 1 to 9. The other thing is we're going to drop all unnecessary zeros, and we're only going to keep the numbers of value. All right, so if I want one significant place in front of this decimal, that means that this decimal is going to end just after the 4. So I'm going to start by writing this out as 4 times 10. So now that's my standard scientific notation. But now I want to know what that exponent is going to be. So the exponent is not the number of zeros. In this case it is, but I'm going to show you other examples. It's not the number of zeros. It's the number of times the comma jumps from where it is to where I want it to be. So I take the comma from where it is and I'm going to jump it 1, 2, 3 places. So I jump the comma 3 places. So 4,000 is the same as 4 times 10 to the power of 3. If I have 1 million, so now I have the number 1 million. Is 1 million a big number? Absolutely. It has all its zeros at the back of the number, so I'm going to put my comma in. Now, where do I want my comma or decimal point to end? I want it to have one significant value before it, so that's just going to be the 1. So if I were to write this out, I would write it as 1 times 10 to the power of something. Now that something I'm going to determine by taking my decimal point and moving it to where I want it to end up. So that's 1, 2, 3, 4, 5, 6 places. So 1 times 10 to the power of 6. Now I have a number like 85,000. So now this is a big number, the zeros are at the back, all right? If I put the comma in, I put the comma at the back. Now, if I were to put the comma there would then be 2 numbers in front of the decimal comma, and there can't be 2 numbers in front of the decimal comma. There can only be 1 number in front of the decimal comma, which means that my decimal point is going to land between the 8 and the 5. So that means that I'm going to have 8.5 times 10 to the power of something. That's taking this decimal point and moving it 1, 2, 3, 4 places. So now I have 8.5 times 10 to the power of 4. Now I have 47,010,000. Now this is going to bring me to a little side note. If I have the value 101 and I have the value 11, now 101 and 11 are not the same. Why? Because the 0 is in between the two ones. There's a 0 in between the two ones, and that 0 is acting as a placeholder or a place value, and that is creating my number 101. So if I were to erase that 0, then I'm changing the value. I'm going from 101 down to 11. So that's what I want to mention here. Because over here, we have this 0 in between the 7 and the 1. Now that 0 is creating a significant value. So I'm going to put my decimal point at the back. When I want one significant value in front of the decimal, that means that my decimal point is going to land between the 4 and the 7. So I'm going to have 4.7. Now I'm not going to drop that 0 because that 0 is a placeholder, 0, 1, and I can drop the other zeros. Times 10 to the power of, and now I want to find my exponent, so I'm going to jump my decimal 1, 2, 3, 4, 5, 6, 7 places. Now what if we take small numbers like the value 0.002? Alright, so this is a small number. The zeros are in front of the value. I still want one significant value in front of the decimal. So I'm going to move this decimal point to the back, okay, so that there's only a 2 in front of it. So this is going to be 2 times 10 to the power of something. So now I want to find that something, and that exponent is based on the number of jumps it takes to get from where the decimal is to where the decimal needs to end. So that is 1, 2, 3 jumps. So my exponent would be a 3. But I'm working with a small number, so my exponent is a negative 3. So I have 2 times 10 to the power of negative 3. Small numbers, negative exponent. So now we need to keep that in our mind, that if we're working with big numbers, we have positive exponents. If we're working with small numbers, we have negative exponents. So that way, when we're going from the big number to the scientific notation, it will be a positive exponent. And if we're going with a positive exponent scientific notation into the ordinary number, it will also be a big number. So you need to link big number, positive exponents, small number, negative exponents. All right, if I have 0.000000515. Now I see this is a small number, all my zeros are in front of the number. So if I were to put my decimal points at the back of this value over here, then do you agree that it will be 515 point something? So I'm not going to put it at the back because I only want one significant value in front of the decimal. So I'm going to put it just after the first 5. So now when I write this out, I'm not going to drop my significant value, so I'll have 5.15 times 10 to the power of. Now it's a small number, which means it's going to have a negative exponent. And I jump my decimal. 1, 2, 3, 4, 5, 6, negative 7. Last example of a small number, 0.000103. I have my decimal point in already. Where do I want my decimal point to end? I want my decimal point to end just after the 1 so that I have one significant value before my decimal place. So when I write this out, this will be written as 1,03 times 10 to the power of something. Now that exponent we know is going to be a negative exponent because it's a small number. And how many jumps is it? 1, 2, 3, 4 jumps. So 1.03 times 10 to the power of negative 4. Now what we're going to do is we're going to take some scientific notation or some standard form and we're going to put it into an ordinary number. If I have 1.2 times 10 to the power of 7. What I'm going to do is I'm going to take the 1.2 and I'm going to write it out like that. Now I'm going to look at my exponent, and my exponent is a positive 7, which means that this decimal point is going to move to the right because it's a positive 7, so it's going to be a big number. It's going to move to the right 7 times. So 1, 2, 3, 4, 5, 6, 7 times. So can you see that one of the 7 jumps had to get past the 2? So actually I get past the 2 with 1 jump, and then I'm going to add 6 zeros on. But I'm just going to fill in zeros in these spaces. So now I count in groups of 3, just so that I can rewrite my number neatly. And this number is 12 million. If I have 3.675 times 10 to the power of 4, I'm going to start by looking at my exponent, and my exponent is a positive, so that means that this is going to be a big number. So I'm going to rewrite my 3.675, and now I'm going to take the decimal from where it is, and I'm going to jump it 4 places. 1, 2, 3, a 4th place, which means I'm going to add 1 extra 0. So that means that I have 36,750. If I have 5.67 times 10 to the power of 20, if I look at my exponent, I have a positive exponent. It's 20, which means I'm going to have a very big number. I'm not going to have 20 zeros. So what I'm going to do is I'm going to take the 5.67, and I'm going to take this decimal place, and I'm going to move it 20 times to the right. Now remember, we need to move it past 2 numbers to get past the 6 and the 7. So I'm going to jump it 1, 2. Then, do you agree? There are 18 left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Then I'm going to fill in zeros in all the little gaps. All the little gaps, I fill in zeros. And then I'm going to rewrite this number nice and neatly. What if I have 2.75 times 10 to the power of negative 5? Alright, so now if I look, I have a negative 5, which means that this is going to be a small number. Now, when it's a small number, I like to write the decimal at the side of the page so that you have space to fill in the zeros in front of the number. So when I rewrite it, I'm going to just put the 2.75 kind of on the side of my page. Now I know that I'm going to move this decimal place 5 times. 1, 2, 3, 4, 5. But it's a small number, so I have to put the decimal point back in and put a 0 in the front. So now I'm going to fill in my zeros. So that means that I have 0.000027 and a 5. Last example, 4.9 times 10 to the power of negative 10. Alright, so if I have negative 10, I know that that's a small number, which means that I'm going to write my 4.9, my decimal, kind of at the back of my page. Now I'm going to take this point and I'm going to jump it 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put it back and fill in a 0. Now I'm going to put zeros in all of the gaps of my jumps, and I'm going to rewrite this as 0.0000000049. I hope you found this video helpful. Stay tuned for another video on how to multiply scientific notation, divide scientific notation, and raise it to a power.